What's up, math fans? I want to introduce to you something called trigonometry, the study of angle relationships, angle and side relationships in right triangles. So I hope you're good with right triangles. If you're not, you can check out some old videos I did on Pythagorean theorem. Similar triangles is helpful, and basically ratios and proportions is also helpful because they use all of that to discover a whole new branch called trigonometry and setting up trigonometric ratios. Okay, so in the Pythagorean theorem video, you'll learn some vocabulary like hypotenuse and opposite. So if you're looking at a right triangle and you're familiar with the hypotenuse, you know it's the longest side, also known as the side that's opposite the right angle. So you should know opposite means over there. And by that information, adjacent means over here or right next to me. So first thing you want to do in questions like this, label your three sides. I'm looking at a right triangle, I should be able to know the hypotenuse right away. Then it depends what angle I'm looking at. So am I looking at angle A or am I looking at angle B? The question will tell you. They'll say Billy's standing over here or Billy's standing over here. I'll start here. Let's say I'm standing over here. I'll call this angle B or angle X or angle theta. New symbol, theta. Theta, all right? It's Greek. And they use this symbol just to represent an unknown angle. So they started looking at similar triangles, and they know they're similar because they're in proportion. And I'm allowed to build these triangles because they're very famous triangles. This is 3, 4, 5, Pythagorean triple, and this is 6, 8, 10, another Pythagorean triple. And they started to look at relationships. So they said, let me look at the relationships between the sides. What if I put, let me finish labeling. So here's theta. Opposite theta is over there from theta, so this is going to be my opposite, and that means this is right next to me or adjacent to me. Okay? So then they started playing with the different relationships, and they started to notice that when you're looking at similar triangles, you kept getting the same answer. It became consistent. So if I put the opposite side, 8 over the hypotenuse, 10, opposite over hypotenuse. They decided, hey, let's look at this ratio. They got 8 over 10. But then they said, hey, let's look at this similar triangle and see what happens if theta is here and I go opposite over hypotenuse. I get 4 over 5. And guess what? These are equal to each other. If I reduce 8 over 10, I get 4 over 5. So they realized that the opposite and hypotenuse ratio was always the same as long as the triangles were similar. So they noticed that the sine of theta is a constant. It's whatever 4/5 is. It actually happens to be 0.80, but that doesn't matter. It's a constant. It's always the same. And then they said, I wonder if I did that same game for adjacent and hypotenuse, and it worked again. It was always a constant. And then they said, I wonder if I do that same game for opposite over adjacent, and again it worked. So I'm going to teach you 3 formulas. I basically just said it. I'm going to just write it out for you. All right. To further illustrate my point, let's look at this one here. First thing I want to do, just to understand what I'm talking about, is label the sides. Remember that. Always label the sides. So here's my right angle, which means that makes this the hypotenuse. And if it's a word problem, they'll say Billy standing here. Let's pretend Billy's standing here. Here's theta. Now I don't even need ABC as long as I got theta. So if theta is here, where is opposite? It's over there. So this 5 would be the opposite. And this here would be next to theta, also known as adjacent. So you should be comfortable labeling the sides. I don't know what adjacent is, and guess what? It doesn't matter. The goal is, if you understand that as long as the ratio is constant, which I'm telling you it is, you will soon be able to figure out what that angle is. As long as you can make a ratio, you can now find the angle, using, of course, any calculator, graphic calculator. Even scientific can do it too, as long as it has these buttons here, sine, cosine, and tan. Cell phones can do it by now. All right, so let me give you those 3 formulas again. First one, sine theta. The sine of an angle is just basically the ratio of the opposite side over the hypotenuse. the cosine of an angle, cosine of an angle is basically the what? Did I say it already? You should know it then. Pop quiz, what is it? Adjacent over the hypotenuse. And my third ratio is the tangent ratio. The tangent of an angle is the opposite over the adjacent side. All right, that's a lot to write. Mathematicians are lazy, so we took a very, very shortcut. The sine is opposite over hypotenuse. S is equal to O over H. C is equal to A over H. And T is equal to O over A. And then we're so lazy that we just write SOH for this formula, CAH for this formula, and TOA for the third formula. And people call it SOHCAHTOA. SOHCAHTOA is not a word, it's just a way to remember 3 different formulas. It's an acronym, basically. All right, let me get this out of the way, or actually, let's look over here. All I need you to do at the end of this video is be comfortable creating the ratios. We'll soon, in a new video, learn how to use the ratios to find the angle. Right now, we're just creating ratios. Basically making fractions, which any little kid can do. You don't even need algebra for this. So, first we're going to find the sine of A. Sine A. Then tell me the cosine of A, and then the tangent of A. Oh, but you just finished saying that you gotta use theta. Theta means an unknown angle. Here, I'm using A. It's this angle here, okay? So now I know to put the theta there. It really doesn't matter what you're calling it as long as you know where to go. So that basically is saying Billy's standing at A. Once you know where to go, you can label the sides. Right angle, longest side, hypotenuse. If this is theta, over there is opposite, and right next to me is adjacent. So based on my formula, the sine of A is a fraction, the sine of the angle is a fraction, it's the opposite over the hypotenuse. So it's, let's see here, 5 over 13. And for this video, that's all you need to do. Just know how to make the fraction. We'll soon learn how to use the fraction. Right now we're just making the fraction. So, what's the cosine of A? Cosine, cosine, cosine of A. Cosine is adjacent over hypotenuse, so that's going to be 12 over 13. And hopefully you now know that tangent is opposite over adjacent. Opposite is 5, adjacent is 12. So that's 5 over 12. And we're done with that, all right? It's just making fractions, and there's only 3 numbers to play with, so it's hard to miss, okay? But the question also says do the same thing, but for B. So what I would then ask you to do is erase your labels, erase the theta, and now I'm talking about B, so now your theta goes here, and you gotta relabel it. Notice I didn't erase the hypotenuse doesn't change, still the longest side. But now B is here, over there is opposite, and over here is next to me, so that's my adjacent. So try telling me the sine of B, the cosine of B and the tangent of B. You'll notice you're not going to get the same answers, but they're very, very, very similar. You know they're going to be similar. You only got 3 numbers. It's not going to get too crazy. All right? Remember SOHCAHTOA, what it means, what it stands for, and stay tuned to how to use it. All right? Thanks for watching. See ya.